Welcome all participants. Good evening to all. So today we are very glad to introduce our research person, Dr. T. Venkatratnam Garu. He is the technical officer D at NSCL. Sir Venkatratnam sir, are you online?
Yes, sir, I am online.
Okay. Sir, you please turn on your camera if possible. Yeah, thank you, sir. Sir is Dr. T. Venkatratnam Garu. He is Technical Officer D at NSCL Visakhapatnam. So today he will give the topic on introduction to condition monitoring. It is the main. See, as our FDP is two parts. One is computational fluid dynamics, and another one is condition monitoring. So he will yesterday it is started with introduction to computational fluid dynamics. Today it will be introduction to condition monitoring. So from tomorrow onwards, little bit advanced topics, and by the end you will learn completely about this FTP. So in this regard, I request my research scholar Sairam Prasad to introduce our resource person. Thank you, sir.
Thank you, sir. It is a great honor to introduce Dr. T. Venkatratnam, resource person of today's program. Dr. T. Venkatratnam is currently working as Senior Technical Officer at Naval Science and Technological Laboratory, Visakhapatnam. He completed his BE in Mechanical Engineering, ME in Computer Science and Technology, and PhD in Computer Science and System Engineering from Andhra University, Visakhapatnam. His areas of research includes naval acoustic stealth technologies, environmental testing of equipment, condition monitoring, and software development. During his 32 years of service, he contributed significantly on naval technologies like development of vibration and noise control system, such as two-stage vibration isolation system, surface damping treatments, acoustic silencers, etc. Computational studies on design and selection of shock vibration mounts, development of embedded computer-based active noise control system, etc. He was bestowed with awards like DRDO Technology Group Award for development of vibroacoustic stealth products, Outstanding Service Award for contribution to Condition Monitoring Society of India. He has published 25 papers in various national and international journals and conferences. He also guided 8 students for MTech projects. He has associated with many professional societies like Acoustical Society of India and Computer Society of India, and a secretary for Condition Monitoring Society of India. He associated in organizing a number of national and international conferences, workshops on acoustics, vibration and noise control, and condition monitoring. Now I request Dr. T. Venkatratnam sir to take over the session.
Thank you, Sairam. Thank you for nice introduction. Thank you. First of all, I would like to thank Dr. Sastri Garu for selecting me as a resource person for this prestigious program event. My topic is Introduction to Condition Monitoring for Marine Machinery. So I would like to share my PPT. Is it okay? PPT is visible?
Yes, sir.
Yes, sir. It is visible,
Okay,
sir.
thank you. Thank you. Outline of my presentation is like this. First of all, I would like to me- introduce maintenance strategies, and then condition monitoring. What is condition monitoring, and how condition-based maintenance is done in industry and as well as in marine environment. The basic benefits of condition-based maintenance. How vibration, particularly there are several techniques in condition-based maintenance, like thermography, visual inspection, ultrasonic sound, and several techniques are there. I would like to touch upon vibration monitoring and analysis, and some common machinery faults and their symptoms, but some case studies I would like to tell you. So, in most difficult task in vessel maintenance, marine environment is to prevent unplanned downtime to avoid marine related risks. And then machine breakdown in vessels can cause greater risk to the people working in onboard ship. In day-to-day ship operations, structural and mechanical failures can cause serious accidents, placing crew and passengers on board in very dangerous position, inflicting ship damage and sometimes considerable financial losses also. Maintenance models in present scenario is changed. Earlier, we used to maintain the shipboard machinery, short refit, major refit like that. So in 6 months, 1 year, 5 years like that, we have to shut down for schedule period. Whether the machine is down or not, we used to carry out that type of model. Now, maintenance models progress from reactive, that is reactive to preventive and as well as predictive maintenance. Condition-based maintenance is one of the predictive maintenance technique is gaining popularity in marine industry in present days. It is very cost effective and strategic maintenance strategy followed today. There are I, there are four common maintenance strategies followed in industry or as well as in our naval environment. Breakdown maintenance or reactive, these called reactive maintenance or run to failure also. It will be called as run to failure, reactive maintenance or breakdown maintenance. It is fix it when it breaks. And you run the machine, you continuously allow it to run completely till it fails. It damages the complete failure of spoilage for the product. So failure can be a catastrophic, requiring total replacement of the machine. Sometimes not only that individual part, suppose if bearing is failed, not only that, if you leave it like that, it causes some other damage to the machine. So it requires total replacement of the machine. You need to change the pump or motor if you leave it, run it like that till it fails. The cost approximately 3 times more than the repair or replacement of a machine. It is allowed to total failure compared to cost of repair for machine before failure. If you stop the failure, you stop the machine before failure and go for maintenance, it will be some lesser loss will be there for the machinery. If you allow it to run continuously till it fails, the cost will be more than 3 times. Sometimes you need to replace the machine also. Though in then a second strategy is followed by preventive maintenance. In this strategy, fix it before it breaks. Before the failure occurs to the machine, you just fix it for a maintenance. Each critical machine is shut down after a specified period of operation and partially or completely dismantled for a thorough inspection and replacement of worn or defective parts. This is regularly our cars and vehicles are followed. This type of maintenance, preventive maintenance. Improve this. There is an improvement in reliability and availability by eliminating the risk of breakdown. By following this method, there is a lot of improvement in reliability, and availability of machine will also um, useful to the plant. It reduces failures and damages to the equipment due to catastrophic failures. There will not be catastrophic failures because we are planning maintenance at a certain period, certain intervals. So it will not damage the equipment because we are avoiding catastrophic failure. Periodic assembly of every critical or non-critical machine is expensive and time consuming. In this case, we used to assemble and disassemble very periodically for every 3 months or 6 months. Whether it is required or not, we will go for this maintenance. So this causes some other expensive and time consuming in this method. These are some drawback in this maintenance method. A machine which is operating satisfactorily may actually degraded by the frequent disassembly. In some cases, we can find a machine, if you go for this maintenance, periodic maintenance, scheduled maintenance, though it may some other new problem may introduce in the machinery. So this type of problem will be there in this type of maintenance. So people thought of avoiding that sort of unnecessary planned maintenance technique. Then they thought of predictive maintenance or condition-based maintenance. If it is not broke, don't fix it. This strategy is followed. The machine is not in failure mode, don't fix it for maintenance. In this scheduling, maintenance activity only when functional failure is detected. If any heavy excessive noise is produced by the machine, or any rubbing or any other leakage of oil, that sort of problems are faced. At that time, we can schedule a maintenance. Mechanical and any other mechanical or operational conditions are periodically monitored when unhealthy trends are detected. In this case, for troubleshooting machinery, these parameters are monitored periodically. If any changes are found deviating from the healthy condition, then maintenance is scheduled in this predictive maintenance. Maintenance is predicted in advance by trending the parameters of the machine condition. Shutdown for repair can be scheduled at a convenient time. In this case, extensive damage to the machine resulting from forced failure can be avoided. Repair time can be kept to a minimum, resulting in reduced machinery downtime. These are all well understood. That's why safety of the personnel as well as performance quality also improved in this case. Machine in good condition, good operating condition can continue to run as long as there is no problem developed in the machinery. Time and money are not wasted in this case. Dismantling machine that is already operating properly. We need not dismantle the machine when it is running properly. So time and money can be saved in this case. So the another recent method maintenance strategy is followed. Proactive maintenance. Fix it once, fix it at right time. So in this case, proactive maintenance aims to identify and fix the reason for equipment failure before it happens. If a bearing or a gear is failing, or alignment or imbalance is occurring due to some other reason, maybe foundation bolts are loose or foundation is not properly fixed, machine is not properly fixed to the foundation, there will be an alignment issues. Due to that alignment issue, bearing may fail. So this can be identified proactively in this strategy, in this maintenance strategy, and failure can be avoided. The goal of proactive maintenance is to increase asset reliability and reduce the risk of downtime. This each failure is analyzed and proactive measures are taken to ensure that they are not repeated. In this case, frequently some bearings are failing. Um, then there will be some root cause. Alignment issue may be there. Some improper fixing of foundation bolts may cause alignment issues, misalignment issues, imbalance issues, and it will lead to bearing failures. This can be avoided by thoroughly um, studying this, proactively studying the failure reasons. Corrective actions aim at failure root causes and not failure symptoms. Like failure symptoms is some bearing is failed in predictive maintenance. Bearing only will be replaced and the a machine will be assembled. So the correct other root cause may not be addressed in that case. So in proactive maintenance, this root cause can be identified and fixed for further for avoiding further failures. So this is utilized in predictive. This strategy is utilizes predictive, preventive in conjunction with root cause failure analysis. So the central theme of this proactive maintenance is to extend the life of the machinery. Though CBM approach on onboard machinery, how the CBM is used in onboard machinery. CBM in onboard machinery enables continuous monitoring of critical assets such as main engines, propulsion engines, and auxiliary machinery like generators, pumps, and compressors. Measure failure indicating parameters. In this, we need to measure the failure indicating parameters like temperature, vibration, noise, any oil contaminants. Like that, these parameters can be measured for identifying the failures. Look for increase or decrease. These parameters, whether they are increasing or decreasing, is to be monitored uh, properly because based on the uh, baseline measurement signatures. Initially, machine will be running at good condition. Those values will be available with the maintenance engineer. Those can be compared with the present measurement, whether it is increased or decreased. That can be trended over a period of time. So if it is increasing, there will be an alarming sign for impending fault. So this CBM approach to be included as part of integrated maintenance plan. In routine maintenance are planned as periodic maintenance. This CBM also to be included as an integrated plan. So it provides major improvements by integrating in maintenance plan. It provides major improvements in machine availability. The advantages in marine vessels of using CBM: ship crew would be well prepared to arrange their maintenance schedule to reduce or even eliminate overhead costs. Spare parts can be drawn in advance before the machine breakdowns. So inventory can be decreased. Unnecessary inventory can need not be procured and kept in store. This ensures machinery performs at peak efficiency, reducing energy consumption, and as a result, lowers the operational costs. Extends the component shelf life. Say using condition based maintenance, the component shelf life can be extended, making it last longer and better functionality. Unexpected machinery breakdowns are less likely to occur in this CBM, introducing CBM in marine vessels. reduces the cost and maintenance, repairs, and other related expenses. The other then there is a industrial survey made, independent survey made by industrial an average industrial saving. CBM program provide savings of 8 to 12% or preventive maintenance program. Reduction in maintenance costs 25 to 30%. Elimination of breakdown 70 to 75%. Reduction in equipment process downtime 35 to 45%. Increase in production 20 to 25%. Like this, better product quality, improved worker and environmental safety. These are the benefits of condition-based maintenance followed in an industry or in marine environment. So there are several techniques, as I told in the beginning. Machine condition monitoring is the process of monitoring a parameter of condition in machinery such that significant change is indicative of developing failure. So the monitoring parameters can be a temperature, vibration, ultrasonic sound, noise, or any. There are several other techniques are there. Motor current analysis, motor current. This can be monitored, and if there is any indicative change, significant change in the parameter, then we can suspect that there is a developing failure is developing in the machine. So based on this, there are condition monitoring includes this condition-based maintenance includes visual inspection. Generally, by seeing excessive vibrating parts are found by visually we can see. Vibration measurements and analysis, carrying out vibration measurements and analysis on various bearings, gearings. So, infrared thermography. This infrared thermography can identify the hot spots in the machinery or in electrical transformers. If any circuit breakers are heating up, that can be monitored using thermography in electrical plants, thermal plant. So, infrared thermography, oil and wear debris. Most of these bearings machinery is lubricating oils will be contaminated by the wear and tear of gears and bearings. The wear and tear of gears and bearings will be deposited in the oil lubricating oils. This can be analyzed using oil and wear debris analysis. Ultrasonic high frequency ultrasonic measurements can be carried out. This can be used for bearings and leakage of pipings and other areas. These ultrasonic measurements can be used. Motor current analysis is another technique used for condition monitoring. So why do we care about vibration? Vibration is a wasted energy. It's a major cause of premature component failure can occur due to this vibration. Cause of noise as a byproduct of vibration, which contributes discomfort to the people working in the environment. So there is a wear and tear in the components, like bearing, shafting, gears. Due to this wear and tear, there will be an efficiency loss. Response to a problem, vibration is response to the problem imbalance, misalignment, bearing problems, operating conditions, whether the full load or off load, or based on the operating conditions, vibration increases or decreases. So electrical problems also encountered due to vibration. So there may be a looseness of contact of electrical this thing. Worst case, it happens damage also. So for example, this is a typical turbine. Blades are came out. This is a very dangerous scenario. You can see they are supposed to be inside the turbine, but they came out of turbine. So it causes it poses danger to the people working surrounding to the turbine. So this is to be taken care in advance. So any machine deteriorates when dynamic forces increases with the intensity of wear, corrosion, build up, deposit, mass deposits in the turbine blades and the fan blades and the impellers, misaligned forces, piping strains, etc. Which increases with the intensity of dynamic forces. Physical integrity of the machine will be reduced by looseness of mounting bolts, crank or broken foundation, deterioration of grouting, increase in bearing clearances, which reduces the stiffness of the machine foundation, machine which it is supported. So the physical integrity will be reduced because of this looseness and clearances in bearing, etc. There are four forces involved in vibration. Vibration, excitation forces are unbalance and misalignment, mass of the system, stiffness of the system, and damping characteristics. Prior to going into the condition-based maintenance, I would like to introduce certain terminology. So I quickly go through because it is used in vibration condition monitoring and analysis. So basic characteristics of needed to define in vibration is frequency, displacement, amplitude, can be displacement, velocity, acceleration, psych energy, and phase. These three parameters, frequency, amplitude, and phase, are the basic characteristics need to define any vibration problem. So this I can skip. These you people maybe studied concept of simple sine wave. Consider weight mass is suspended or a spring. When it is when upward force is applied on the mass, the displacement will be like this. So when it comes to this direction, so when it moves completely up and down, to and from motion, it forms a sinusoidal wave, simple sine wave form. About a this is the upper position, upper limit, neutral position, and lower limit. So this I need not explain. Simple harmonic motion repeat itself after equal intervals of time, called simple harmonic motion, which restoring force is directly proportional to the displacement of the body, forms its from its mean position. It always moves from the mean position. So period time interval required to complete one cycle of to and fro motion is called period. Number of cycles per unit time is frequency. Amplitude maximum displacement from main position, unit of amplitude mm. Free vibration and peak. You might have all our research scholars and PG students. You might have studied in this terminology. I'm quickly reading it out. It is a free vibration. It is a vibration that occurs when machine or structure is allowed to vibrate in absence of any external force. It is maintained continuous movement with the help of restoring forces only. It is allowed freely when initial force is applied on the machine or any structure. Forced vibration, it is a vibration caused by an external force, such as an unbalanced force on a machine or structure to vibrate. The frequency of vibration, frequency of the vibratory force. Driving force is the frequency of forced vibration. Or if a machine is running at 3000 RPM, the frequency of that machine is RPM by 60 will give the driving frequency of the machine. Natural frequency, it is a frequency at which the machine or structure will vibrate when undergoing free vibration. Most machines and structures have many natural frequencies at which they will vibrate. Any momentary force striking the structure with a hammer can cause excitation at one or more natural frequencies. So resonance frequency is at which coincidence occurs between natural frequency and driving frequency. Usually, the vibration amplitude is more when the driving frequency and natural frequency coincides each other. The critical frequency is this. Critical speed is the speed at which the resonance frequency occurs. This occurs when rotational speed of the machine coincides with the natural frequency of the machine. Critical speed occurs. Damping is the dissipation of mechanical energy associated with vibration. It is an indicator of friction to the motion. Undamped vibration, when it is friction is neglected. This is undamped vibration. Damped vibration. Vibration and friction cannot be neglected. Phase is a very important parameter in vibration measurement and analysis. It defines the position of vibrating part at a given instance with reference to the fixed point or another. In practical cases, this machine is vibrating at point drive end and non-drive end. If you observe drive end and non-drive end, they are in phase with each other. In the other case, between drive end and non-drive end, this machine is vibrating in opposite phase, 180 degrees opposite phase. So this phase information is useful in finding out misalignment and imbalance in machinery faults. So this is the phase relation and phase and magnitude relationship. Displacement lags velocity by 90 degrees. Velocity lags uh, acceleration by 90 degrees, and acceleration leads vibration by 90 degrees. So this can be you can observe. The significance of phase is used in identifying unbalance, bend shaft, misalignment, looseness, resonance, reciprocating forces, eccentric pulleys, and gears. So this is not for routine periodic checks, only for analysis purpose and gives invaluable information as part of the vibration analysis while identifying the machinery faults. When to use displacement, velocity, and acceleration. So while measuring any machinery parameters, which parameter is to be used? Whether displacement, velocity, or acceleration. Displacement is well utilized in low frequency. Is higher amplitude can be obtained in lower frequency zone. When you increase the frequency in displacement, you cannot get the proper amplitude. So velocity is a constant parameter. It is useful in 60 to 10 to 1 kilohertz range. And acceleration can be very useful. It can be in low frequency and high frequency can be measured. Higher frequency is very lot of information can be obtained using accelerometer parameter. This and the same dependence of so if you can see displacement will be very low as velocity is to some extent. Acceleration can be low to very high frequency. It can be covered. this same thing. It's up to 600 RPM, velocity up to 6000 kilohertz. So this vibrational severity levels can be measured using velocity levels only. Vibration severity chart. This is a typical vibration severity chart, ISO 2372. Later, it is modified to ISO 10813. These are different classes of machines with uh, allowable, allowable, and not allowable, good, satisfactory conditions are mentioned in this chart. So this A belongs to up to 0.45, 0.64 RMS value. This is peak value. Velocity measurement in RMS and peak values. So these are the limits, vibration limits of any different class of machinery. Small machinery, medium machinery, large machinery, turbo machinery. Depending upon the power rating, this machinery is classified. Depending upon the power rating, the amplitude, the velocity range levels also changes. So this explanation is the next same vibration severity chart ISO standard is there. In this also velocity levels are measured and compared with the um, whether limits are allowable, good, or satisfactory conditions. These limits are given in this severity chart. Acceleration is the rate of change of speed of mass during the oscillation measured in G's. Acceleration is recommended 120 kilocycles per minute. It is higher frequency range. Spike energy is used for finding out defects in bearing raceways or bearing elements and defects in contact with any other elements. This energy occurs in high frequency and this is measured in the form of spike energy. Special instruments are there to measure spike energy. It's SPM meters are there for measuring spike energies. The basic components of vibration: spring damping, spring dam mass, spring dam mass system. This is a single degree of freedom system and multi degree of system. Single degree of freedom system will consist of a single frequency, single natural frequency. Multi degree of freedom system. Many machinery will have multi degrees of freedom system. It may have, it will have n number of natural frequencies. It is simple. Ideal cases may be a single degree of freedom system, simple mass, spring mass damper system, moving in single direction. This multi degrees. All machineries will be produce multi degrees of freedom system. Is vibration always a detrimental? No. It can be useful in many cases. Component feeders, concrete compactors, ultrasonic leading bars, pile drivers, conveyors, vibration testing machines. For testing any components prior to going to the service, it will be tested on a vibration testing machine. Intentionally created vibrations on the machine to qualify any equipment. So, coming to the condition-based maintenance or condition monitoring, vibration-based condition monitoring, with the typical failure curve defined like this. This is also called Bartek curve. It is generated by mapping the rate of early infant mortality failures when first introduced. This is the rate of random failures with constant failure rate during its useful time. And finally, the rate of wear out failures are at the end of the product or its design lifetime. So in early lifetime of the product, the failure rate is high but rapidly decreasing as the defective products are identified and discarded. This phase is called infant mortality. In the midlife of the product, the failure rate is low and constant. This is useful life or expected useful life of the machine or any product. In the later life of the product, the failure rate increases with the um, probability of failure. So many electronic equipments or consumer products cycle strongly behave this failure mode. So what is condition monitoring? Over a period of time, sorry, parameters are trended over a period of time, whether how the uh, levels are increasing over a period of time. If there is any increase is observed, then here you need to go for maintenance, which this indicates the condition of the machine. So the typical CVM elements, transducers, acquisitions, data acquisition systems, and post-processing, measuring and automation softwares or post-processing softwares are used. There are three powerful CBM techniques used. Condition-based techniques are machine condition monitoring, vibration analysis, infrared thermography, and oil and wear debris analysis of the three very powerful CBM techniques can be used in any industry to follow their maintenance activities. So I will discuss only on vibration based condition monitoring. So all machineries will vibrate, which each vibrating machinery will produce unique set of vibration components like this. Unique set of vibration components. Vibration increases machine if the vibration of the component will be increases if there is any impending failure occurring in the machine. So this philosophy is used in identifying the machinery faults. This is a cause and effect diagram. So due to wear out and uneven loads, unbalanced rotor, defective bearing due to aging, wrong mounting in the housing, soft footing and misalignment due to skewness, motor feet, worn out base frame, increased clearance in the bearing housings due to wear out, improper alignment of the bearing, problems in mechanism, unbalanced mechanism, bent shaft, design error or jerky loads, jamming of mechanism. All these problems lead to high vibration in the machinery. So for any vibration condition monitoring, data acquisition is most important and critical and for successful analysis. And therefore, we need to collect accurate data. How do we the steps involved in carrying out vibration analysis? First, identify the machine and know its RPM or collect the machinery parameters like RPM, the speed, speed in RPM, then power rating, type of bearings used, gear train is used in the machine. If it is having any belt driven or uh, what type of bearings used, and if it is a fan, how many number of blades, the pump impellers, the number of vanes are to be note down. All these parameters are to be note down before acquiring the vibration data. So these are useful. These readings are useful in diagnosing faults in the after collecting data and analyzing the data. These parameters are very useful for identifying the proper fault. So these are typical steps used in vibration-based condition monitoring. There are 5 steps: sense, condition, record, display, and analysis. Acquire the vibration experienced by the structure using a transducer, which converts the vibration motion into electrical energy. These transducers can be displacement probes, velocity probes, or accelerometers. These the the sensor output will be very high in required to be uh, um, amplified, because it low level high impedance output will be produced by the transducer or sensor. This a preamplifier is required to convert the low level high impedance output of transducer into a low impedance signal. The sensor output signal is stored digitally with a data collector record. We have to record in a data collector, or earlier we used to use tape recorders. Now the memory devices have come. These data collectors are holding lot of data in the unit. This analyzers. Then display and analysis instrumentation is used for viewing the signal and in the time domain or frequency domain. For time domain, oscilloscope like things can be used. For a frequency domain, FFT spectrum analyzers are used. So then after displaying and doing the analysis and displaying the spectrum, you need to diagnose and identify suggest the proper remedies to the diagnosed faults. As each machine defect produces unique set of vibration components that can be used for identification. This correlation between vibration components, which defects, is the basis for identifying the faults. Suitable remedial action for repair and replacement of the components can be suggested at the end of the analysis. The typical instrumentation setup: the machine is mounted with an accelerometer and is connected to a simple data collector or a spectrum analyzer. It's very old equipment. Now, a recent portable equipment have come available in the market. Though for acquiring any vibration data, locating the sensor is very important. Very based on the location of sensor accelerometer or sensor uh, on the machine gives proper information for analyzing and diagnosing the fault. Vibration measurements on machines should be made preferably at the housing of bearings or nearby measuring points. Basically, all the measuring points should be on the bearing housings, which are load bearing points of any rotating machinery. For routine monitoring, it is sufficient in many cases to measure vibration either in vertical or in horizontal direction. Not only single direction, we need to measure in vertical, horizontal, and even axial direction also. We need to measure in all 3 directions. Whether it rigid, there are 2 cases maybe rigidly mounted. When machine is mounted directly on the rigid foundation or on a flexible foundation matters. Rigidly mounted cases, horizontal shafts have their highest vibration levels, mostly in horizontal direction. For a rigidly mounted cases, for a flexibly mounted machinery, may have high vertical components. vertical vibration components. So for inspection, vibration should be measured in all three directions: vertical, horizontal, and axial at all bearings. For diagnosing any fault, so you need to measure in all three directions. So typical how to choose a mounting position. So if it is a bearing housing like this, it should be directly contact with the bearing. So in case A, bearing is directly connected to the structure. So in this case, there is an air gap. So this is not a suitable, preferable mounting position. Like that, this is not a preferable mounting position. You should when it is in when you wanted to mount in horizontal axial direction, you have to locate. Sorry, locate at this position. This position. So in other view, this is horizontal direction. This is in vertical direction. This is axial along the axis of the shaft. Axial, horizontal, vertical. So if you see in three-dimensional view, this is axial direction, vertical. Both the driven and non-driven, you have to measure the vibration levels. This is a typical coupled machinery. You need to measure.
Sir, you please hide it, sir. That screen is coming pop up.
Sir.
Thank you.
Sir. Shall I continue, sir?
Yes, sir. Yes, sir. Please. Actually, some figure names it is not visible. That's why.
Okay. Now it is okay, sir.
Yes, sir. Yes, sir. Thank you.
So this accelerometer mounted on a typical gearbox like this. So any accelerometer will have some certain useful frequency range. So 70% of natural frequency of accelerometer will be response will be flat. You can measure, you can select the frequency range up to 0.3 f0. F0 will be the natural frequency of the accelerometer. This will be given by the manufacturer, provided in a form of charts. You can read the chart and you can go measurement up to this frequency range. So the mounting accelerometers, there are different variety of mounting blocks mounting methods are used. These are typical wax is used, base wax is used for mounting, for temporarily mounting. So thin double adhesive tape is used for mounting on a machinery. Cemented studs are used, stud mounting are used. Even magnetic mounts are also used. Magnetic surfaces. This response of each mounting method have its own frequency response. So it differs. Among them, stud mounting is rigidly fixed onto the machine. So more frequency range will be covered in stud mounting. Some handheld probes are also used when you are unable to locate access the points. Handheld probes are used. Inverted probes, magnetic mounts, as I told. This magnetic surfaces, magnetic mounts are used on magnetic surfaces. So magnetic surface and probes will give more frequency response, whereas handheld probes will give less response. This is a typical principle of accelerometer. Accelerometer is a spring mass damper system. Most these accelerometers are made up of piezoelectric accelerometers, made quartz crystal, piezoelectric ceramics, high temperature operation. For high temperature option, tourmaline and lithium niobate is used. These crystals are piezoelectric elements. These are piezoelectric elements. This is a seismic mass. This is centropose supported spore. This will be represented like spring mass system. So the accelerometer obeys Newton's second law, F is equal to mass into acceleration. Whenever this vibrating force is applied onto the crystal, yes, the piezoelectric crystal will produce equivalent charge output or voltage output, which is converted. Charge output will be converted into voltage. Equivalent mechanical output into equivalent electrical output. These accelerometers are widely used in vibration and even shock measurements. This is a typical triaxial accelerometer, single axis accelerometer, single axis sensor. This is a triaxial sensor. At a time, at once, it measures all three directions. So when coming to the analysis part, there will be two types of analysis: waveform, time domain analysis, and FFT spectrum, frequency domain analysis. So what is FFT? So normally in any vibrating signal collected by the accelerometer will be look like this. So it consists of complex waveform having combining so many components when it is split into various waveforms. This complex waveform is split into different sine waves. This FFT will do the breaking waveform, the complex waveform into different sine waves, and it converts into frequency domain. This is the typical sine waveform of a complex signal is split into simple sine waves. When it is converted into FFT, it looks like that. This is the first component. 1, 2, 3, 4, 5. All these components can be clearly visible in FFT spectrum. So for this is a typical sorry. Typical FFT spectrum of a normal machinery and faulty machinery. You can see vibration levels of normal machinery when sine waveform, composite waveform is converted into FFT, it looks like this. So for an abnormal machine or faulty machinery, composite waveform is converted into FFT. Abnormal. So here you can see the peak. This is increased. This second peak is abnormality can be detected in the frequency range, whereas you cannot identify in this complex waveform. You see, in this complex form, which component is producing problem, we cannot identify. So this time domain signal is converted into FFT to identify the defects in any machinery. The problems causing high vibration due to unbalance, looseness, defective bearings, electric problems, hydraulic forces, misalignment, eccentricity, defective gear, resonance, aerodynamic forces, etc. So these are typical frequency components. Likely frequency causes and frequency components are displayed in this table. For example, imbalance 1 into rotational frequency in the direction of radial dynamic imbalance, possibly uh, axial measurement also to be taken. Amplitude is proportional to imbalance and RPM causes severe vibration to occur. During imbalance, 1 into RPM rotational frequency component will appear in the FFT spectrum. So misalignment bend shaft, 1 into rotational frequency, often second harmonic also appears with a higher multiples. Radial and axial direction measurements are to be taken uh, to identify this misalignment or bend shaft. Severe axial vibration and second harmonic best realigned with some alignment equipment. With the bearing damage, high frequency vibration can be seen in the spectrum. Radial and axial direction measurements are to be taken. May be diagnosed from vibration only through use of diagnostic functions or shock pulse meter also. SPM analysis also can identify the bearing faults. That this typical vibration frequencies that are appearing in FFT spectrum and likely causes is tabulated in this table, like gate tooth damage, belt drive damage, hysteresis burial, turbulence cavitation, electrical induced vibration. All these can be appeared in the vibration spectrum in the FFT spectrum. There are two levels of condition monitoring strategies. One is trend monitoring, and the second one is signal analysis. So trend monitoring will be monitored a single parameter, vibration, velocity, or displacement over a period of time. So weekly or monthly, these parameters are monitored, and if there is an increase in the trend, then you can go for a detailed vibration analysis. Spectrum analysis can be done. Measure the vibration spectrum using an accelerometer, and 50 spectrum can be uh, plotted. From this, defect can be localized in the vibration spectrum by seeing these spectral components. Amplitude. So, if all machinery are frequency generators, then what components should I expect? So all these components will be structure, machine foundation structure, bearings, fan, shaft, blades, any belt is there. All these components will appear in the FFT spectrum. So like motor 18.5 produces 30 Hz in the order of motor speed in the order of 1, belt 720 RPM, frequency 720 by 60 comes to 12, fan shaft 900. Like this, all the bearing, roller bearings. Again, roller bearings will give all cage frequency, inner race frequency, outer race frequency, ball spin frequency, cage frequency. All four components will be present in the vibration spectrum. Structural frequency also. All these components will appear in the vibration spectrum. So typical FFT looks like this complex FFT waveform, which is FFT breaks into simple sine waves, and when it is converted into frequency spectrum, all the component turning speed, twice the turning speed, bearing frequencies, blade pass frequency, all these components will appear in the spectrum. These are the typical FFT analyzers currently available. These are data collectors. Portable data collectors are also available. in the market for acquiring vibration data and identifying the machinery faults. This is a multi-analysis system, 64-channel multi-analysis system. In shipboard machinery, we used to collect more points, more data at a time. This type of analysis system is used. The common machinery, these are the common machinery faults in any machine. Typical motor with the gearbox and impeller fan is this mechanical looseness, soft frequency, electromagnetic related mechanical resonances, alignment issues, bent shaft, gear, unbalance. Sorry. Bearings, general bearings, rolling element bearings, all these common machinery faults can be identified using analysis. This can be identified in the vibration spectrum. Typical imbalance whether static or coupled, results in a spectral peak at a frequency once for a revolution like this. So this moving I am unable to control. You can see this is single component. Imbalance. This simple one component is appeared. This pure sine wave will appear in a scope. If you convert into FFT, a single component will appear. So it increases with the speed of the machine. There are static imbalance, mass and shaft are center line when excessive mass is in center line with the shaft axis. The static imbalance. Coupled imbalance will occur when shaft center line and mass center line are deviated, the non-parallel. In the both cases, this 1x component will appear in the vibration spectrum. For identifying imbalance, where exactly locating the unbalanced mass, phase measurement is to be taken. Rotating nature of imbalance force results in a phase reading relative to the key phasor that follows the transducer location. This is very useful in differentiating imbalance from the faults which produce direction of the vibration. So, phase in addition to the two directions or three directions acceleration measurement, you need to take the phase measurement also to identify the exact location of the unbalanced mass. So, in misalignment or bent shaft, any bent shaft or misaligned shaft results in high vibration levels, high axial vibration levels. Along the axis of the shafts, high vibration levels can be found in the vibration spectrum. Alignment problems are usually characterized by the large 2x component. This you can see is a 2x component in the spectrum, which is very high when compared to the fundamental frequency. So mechanical looseness, a typical mechanical looseness spectrum appears like this. In time domain signal, truncated waveform is appeared in the time domain, and the frequency domain, multiple harmonics are present. The upper graph, multiple harmonics are present in the spectrum. Whereas in the time domain signal, truncated vibration waveform is seen. Due to the truncation in the sine wave, the multiple frequency components are appeared. So if, this is a typical loose bearing cap. Due to the loose bearing cap, the spectrum appears like this. So this can be attributed to looseness of the bearing cap. Bearing defects. There are four type of bearing defects can be identified. Typically, bearing number of these for identifying bearing faults. These parameters are to be recorded for initially. Number of balls, ball diameter, pitch diameter, contact angle. Though based on that, defect, outer race defect, inner race defect, ball defect, fundamental train frequency or ball spin frequency can be calculated based on the bearing parameters. These frequencies components will characteristic frequency components will appear in the vibration spectrum. Well, if any defective bearing uh, produces these components dominantly in the spectrum, based on the by looking in this matching the component frequencies in the spectrum, we can identify these faults, uh, bearing faults, whether it is belongs to outer race, inner race, or ball spin frequency, or fundamental train frequency. The typical outer race defect is shown in this spectrum. So this first one is running speed, ball frequency, ball pass frequency, and twice the ball frequency, thrice the ball pass frequency attribute to outer race defect. This last component belongs to gear mesh frequency also. They appeared in this spectrum. Bearing defects. Impulsive nature of bearing defects produces large number of harmonics spaced at the characteristic frequency. Any ball or inner race or outer race is having some dents in the when their race or ball. So this type of impulsive nature of spectrum will appear in this spectrum. So this is space with fundamental frequency, the speed of the shaft. This difference between these two components will be the speed of the or frequency of the fundamental frequency of the shaft. So this attribute to some bearing defect, impulsive in nature. Before this is a typical bearing defect spectrum. Before replacement of bearing, this high frequency vibration is seen in the upper graph. After replacement of the bearing, those multiple harmonics and other components are disappeared. This amplitude is around 3.5 to 4 millimeters per second, whereas in this case 0.6, 0.4 to 0.5 per second. So after replacing the bearing, so by looking by seeing this spectrum, we can identify bearing problems in any machinery. This is another this high frequency amplitude has reduced after before bearing replacement. These fundamental components around 2.45 meters per second, and in this case after replacement 0.9 per second. Even high frequency components have reduced after replacing the new bearing. This is a typical gear faults. Characteristic spectrum of gears set in good condition contains components due to running speed of the both shafts and gear meshing frequency. This is a good gearing problem. This is the running speed input shaft, running speed of the machine, and high speed shaft gear mesh frequencies are appears. So the gear train is there the pinion gear and other main gear. So these two shaft frequencies can be appeared in this input shaft frequency and high speed shaft frequency also appeared in the spectrum, as well as gear mesh frequencies also. These gear mesh frequencies can be calculated based by taking the gear train ratios and all. The typical gear faults, running speed, gear natural frequency, gear mesh frequency. So, gear natural frequencies excited by impulses from large defects are often only indication of problem. This is a typical zoom spectrum of gear natural frequency. This when this gear natural frequency is zoomed, this running speed, there is a spacing of components appear in this um, spectrum with the running speed spacing with a spacing of running speed. Gear natural frequency side bands will appear with a spacing of running speed, which indicates the bad gear. Bad gear, the maybe tooth is broken or worn out. This can be the this can be attributable to worn out or broken teeth in the machine. These are typical blade faults. Multiple a space in the vibrations signal caused by a missing blade results in a large number of harmonics. Because of missing blade, there will be an unbalance. Due to unbalance, significant for 1x component will appear in the fourth graph. 1x component where increasing with speed increases the amplitude. The typical resonance. Resonance can be identified using spectral maps or waterfall diagrams. Then coming to the some case, I would like to present some case studies. Sir, shall I continue, sir? Hello.
Yes, sir. Yes, sir. It's your wish. How many slides are there?
These are case studies with 5-6 case studies are there, sir. With this, I will
Sir, you please, sir. No one will tell in this universe like you. You have done very elaborately.
Thank you.
If we
Thank you.
miss again, it is. You please take it, sir. All are listening. You are.
Thank you.
It is not boring. It's. You are really, because you are a practical man. You are giving a wonderful lecture. Please
Thank you.
continue, sir.
Thank you, sir. Thank you, sir. These are typical. These are the practical case studies I would like to present. Fault diagnosis case studies. The typical motor-driven compressor. We have carried out vibration measurements at HPCL. They are called as their compressor is shutting down with high vibration levels and high noise. We have carried out vibration measurements at the various points, the various bearing points on motor side, compressor side, and gearbox. These are the various monitoring points located 1, 2, 3, 4, 5, 6 at both vertical as well as horizontal and axial direction also to obtain the maximum information from the machine. We observed presence of high vibration levels at multiple harmonics of shaft rotational frequency. This machine is running at 3000 RPM. So the fundamental frequency is 3000 by 60 50 Hz. It's dominant in the bottom spectrum. You can see 50 Hz components are dominant and its harmonics are also present. So multiple harmonics are present. This presence of multiple harmonics is attributable to mechanical looseness, as we have seen in the earlier slides. So this is a typical of phenomena and fault symptom that can be appeared in the vibration spectrum. This presence of high vibration levels at multiple harmonics of shaft rotational frequency, that is at 50 Hz, is attributable to mechanical looseness. We recommended to check for looseness of coupling between the compressor and the gearbox. So they have dismantled and found a crack in the key of the shaft coupling. So they found a split in the key. So due to that the physical integrity loss of physical integrity, so this whenever the speed the rated machine is running at rated speed, this compressor is producing a lot of noise. So and this type of spectrum is appearing in the analysis. So this is a typical classical case study of misalignment. So they reported us the found crack in the key of the shaft coupling. So when they replaced it and the vibration levels have come down. Another case study, fault diagnosis of typical gas turbine generator, Gatagay. We call it as Gatagay. The presence of high vibration at 1x, 1 into RPM. As usual, we have selected various locations, monitoring points, and measured the vibration levels in all three directions. And typically at compressor and reduction gear, at point number 3, this spectrum is obtained. So in this spectrum, you can see that this component at 210 Hz and 420 Hz, fundamental and its harmonic. 1x RPM and 2x indicate misalignment between compressor and the reduction gearbox. We recommended to check for misalignment between this compressor and reduction gear. They found they reported as they found 0.1 mm misalignment instead of 0.03 mm permissible level. So actually, it is supposed to be 0.03 mm misalignment should be there between these two compressor and reduction gear. Instead of that, they found 0.1 mm misalignment. So immediately they used some shims and other techniques for aligning the shaft coupling, and they found the components disappeared after rectification of the problem. This is another case study of turbine alternator feed pump. This is a turbine alternator pump. We have, as usual, we selected various measuring points and collected data. This is not a single spectrum I am showing. There will be a lot of data will be collected. Among them, we have to eliminate certain various points and close when we have to measure, locate several accelerometer sensors on the machine to identify the exact location of the fault. So because there may be a alignment issue with main motor pump, main feed pump and alternator, or alternator and a turbine. So when you monitor more number of points, you can vibration is directive, and it is a directive phenomena where the fault is located. So amplitudes will be more towards the fault location. So, accordingly we monitor several points, locate several points and measure uh, vibrations at different locations. And this is typically obtained at um, pump and the alternator, main feed pump and the alternator. With this similarly found shaft rotational frequency and its second harmonic. So main pump and drive end and attributed to this phenomena attributed to 1x and 2x phenomena attributed to misalignment. And we also found the phase also. When an alignment is there, will be the phase difference will be also found due to the alignment. Phase measurement is not depicted here. So based on this, we recommended alignment between main feed pump and the alternator. So they checked the alignment, and we have repeated the measurement. They rectified the problem and repeated the measurement. The vibration amplitude set fundamental and second harmonic is reduced after alignment. The red curve indicates before diagnosis the problem exists, and the blue curve indicates the after alignment. So this fundamental and second harmonic disappeared in the spectrum. This is another case study of a typical marine shafting problem, shafting vibration levels. We have measured this shaft is supported at four plumber blocks, plumber block 1, 2, 3, 4, and we have measured at all four locations. The only overall vibration levels are measured in this case. No FFT spectrum is taken. Overall vibration levels in velocity meters per second, mm per second. Vibration levels are high in horizontal direction at plumber block 2 and 4. This is 1, 2, 1, 1, 2, 3, 4. These are plumber blocks 1, 2, 3, 4 plot, bearing locations. So at these four locations we have measured. At 2 and 4 we found this increase of velocity levels. At plumber block 1 and 2, 1 and 1, 3 and 4 are the one are good. Where levels are low. 2 and 4 vibration levels are very high. So we suggest we further analyzed and checked the for support for plumber block support, and we have suggested to provide extra stiffness, extra support and strengthening horizontal direction. These two plumber blocks for the 2 and 4, the levels have come down after to the acceptable level. So you can see this. This is a acceptable limit in green line, and below that pink line after stiffening the plumber block supports. So this is another. So this is another case study of a typical pump. So this is a classical misalignment case. So we observed so shaft rotational frequency and its multiple harmonics. Before modification, the levels are very high in horizontal direction, particularly in horizontal direction. Then we suggested some. These are typically is structure supported structure vertical beams. We suggested to stiffen give the supports horizontally to the vertical beam supports, and they welded some structure along the to stiffen the vertical beams. So then they provided extra support in horizontal direction. So after modification, the vibration levels have come down, and the multiple harmonics also disappeared. So this is another classical fault diagnosis case study of a vertical condensate pump. This case study is taken from RCF Mumbai, the RC Chemical Fertilizers. They are presented in our one of our conferences. For industrial case study to demonstrate in an industrial case study is taken this. This pump is producing abnormal sound pump bearing with rising vibration trend. While measuring vibration of a pump bearing, there is a trend of increase in the bearing vibration levels. These are typical specifications of centrifugal multi-stage compressor running at 1500 RPM, pump bearing, deep groove wall bearing 6317. This data to be collected as I told. There is a coupling pin bush type. Vibration trend data is taken over a period in the month of August 12th, 28th, 29th, 30, and 31st, like that. This motor, both the motor drive end and pump bearing side, vibration levels are taken, overall vibration levels only. So these levels are increasing at pump bearing. You can see, sorry. pump bearing vibration levels are increasing, or the 1.9 to 2.3, 1 to 2.5, 0.9 to 7.9, and 7.9 to 10, 10.4, 11.27, like that. Or while trending this vibration data, it is increasing. Vibration signature analysis indicated dominant frequency component at this 35.65 kilocycles per minute. Rising vibration trends. They recommended replacing the pump bearing. This will be a clear indicator of increase in pump bearing vibration levels. So they asked them to replace the pump bearing. So after finding removing the bearing, so inner race defect is found. There is a dent in the inner race, and the damaged ball also can be seen in the photo. So after replacing the pump bearing, the vibration levels are again taken. So these are the pump bearing vibration levels, increasing trend. After replacement, the levels have come down 1.6, 0.9, and 7 to the normal values. With this is the typical machine monitoring system, multi-channel for pumps, fans, turbines, for rotating machinery. This type of machine monitoring system can be used. Way back to 90s, Anestil has developed an online vibration system for shipboard machinery, particularly for gas turbines and diesel engines. Very in 90s, the primitive model. So this system indicates the alarming levels when this is a typical four-channel analyzer. Four monitoring points are connected to this analyzer. When the vibration continuously monitored, when the levels are increased, the alarming reaches the alarming levels, it produces an alarming sound. Then they will go for detailed vibration analysis and or for any maintenance activity. So why vibration is preferred in CBM? Because temperature can identify misalignment, damage rolling element bearings, journal bearings, and pressure monitoring can only identify the damaged journal bearings, flow bearings, journal bearings, oil analysis, damage rolling bearings and journal bearings, worn out gears also. In vibration, all this out of imbalance, misalignment, bent shaft, damaged rolling bearings, journal bearings, damaged worn out gears, mechanical looseness, noise, cracking, everything can be identified by the vibration data. So the vibration is the best indicator of machine health. So vibration is preferred for condition-based maintenance. So instead of only vibration, an integrated condition-based approach can be followed by using more than one technique. Very early warning equipment's problems can be obtained. Some problems manifest themselves early in the thermal imaging or lubrication analysis. The same would have appeared later in vibration measurement. The reverse of this is also true. A suspicious gear on a gear wear through vibration technique gets confirmed through wear particle analysis. Vibration after doing a gear can be suspected in vibration analysis, and it can be confirmed by the wear particle analysis. The gear wear can be observed in the wear debris analysis. That is supplemented to the vibration based condition analysis. The combination of all these three techniques of condition monitoring leads to very early warning, root cause analysis, enhancement of overall equipment effectiveness, maintenance cost reduction, and better space management. These are the references that you can go through. And thank you very much, sir.
Thank you very much, sir. I request all the audience unmute individually and ask questions. Sir, one Kannan, he is asking a small question, sir. What is the software used for condition monitoring? Is there any specific software or
There
software
will not be any specific software, sir. These analyzers will have the customized software.
customized? They will supplier will
They
give.
will
Who
supply
are the
along with the
suppliers, sir?
analyzer. Yes,
Who are
sir.
the suppliers?
Suppliers are now there. Many suppliers are there, sir.
Okay.
Proof Technique, SPM, uh, ABB.
From that instrument itself, they will supply the
Yes,
software.
sir. This
Not
analysis,
like the
whatever the
CISA.
spectrum that we are getting in the analyzer, it includes the FFT algorithm and
Yes, sir,
everything,
yes,
sir.
sir. It is inbuilt software.
It is inbuilt. Even now people are working on own codes, developing their own codes for
Okay.
bearing fault and diagnosis and other using MATLAB. People are based on the vibration data available with the uh, user. This data can be interpreted for faults using a MATLAB code. Some expert system you can develop on your own based on the symptoms and faults and symptoms. You can incorporate this knowledge into an expert system and you can find out the faults. Some people are working on expert systems, artificial intelligence based system, and ANN based, and this AI and ML is also used in identifying, particularly for gearing and bearing faults.
Okay, sir. Thank you very much, sir. The audience, any questions from your end?
Sir, good evening, sir.
Good evening.
Yeah, please introduce yourself before because sir also know. And if you can turn off your camera, it will be good.
Sorry, sir. Sir, actually, sir, my name is N. Rajshekhar. I'm Sasi Institute of Technology, Tadepalligudem, sir.
Okay.
Sir, first I want to thanks Ratnam, sir, and his organizing committee. Sir, thanks for all your neat and good theoretical explanation as on root causes of vibrations and its measurements in marine vehicles.
Thank
Sir,
you.
here my first question is, sir, usually till now we discussed about all the possible vibrations at different locations, which are propelled by with the diesel engines only.
No,
And
no,
now,
not only
sir,
diesel engines,
okay,
any machinery.
okay.
Any
So,
machinery running at their own characteristic speeds.
okay, thank you, sir.
Okay.
And coming to this one, sir, advanced technology vehicles, I mean, mainly underwater vehicles as far as concerned, it's one. So, sir,
Okay.
can you tell the what are the possible ways of vibration and its control, sir? Coming to nuclear powered vehicles, sir, like uh,
Uh,
ad- advanced technology vehicles, sir.
Autonomous vehicles, like
Not autonomous, nuclear powered. So that is completely powered.
any nuclear powered or any powered any conventional powered machines also,
Yes, sir.
it will produce its vibration characteristics uniquely. So if a
Okay.
nuclear powered machine running at some frequency, some speed, it
Yes, sir.
produces these type of frequencies, the components.
Sir.
The accelerometers can pick up their responses in time domain and frequency domain. You can
Yes,
convert the time domain signals into frequency domain, and you can characterize those frequencies. You need to have the machine that whatever the nuclear powered machine, that turbine or any other equipment, those
yes, sir.
frequency components you need to calculate before going for any analysis. So
Okay, sir.
that can be appeared in that vibration spectrum.
Okay,
Vibration
sir.
sensors will do the same job for any, even for a pump or a compressor or
Yes, sir.
for a diesel engine or a turbine.
Yes,
Anything,
sir.
this vibration characteristic is unique.
Okay, sir.
Each machine defect produces unique set of components. Like if a bearing is producing, you can see that bearing components at some frequency band,
Yes,
bearing
sir.
resonances at some frequency band, gear
Okay, sir.
natural frequency at some band. Those
Okay, sir.
you need to identify by calculating those parameters on hand.
Okay. See, comparatively, mission powered vehicles, there are a lesser number of spots are required, na, sir, comparatively nuclear powered, because in all mission concerns, sir, there are number of coming to the engine of the base and its shaft, propeller shaft, and
Hmm.
everything, sir.
Oh, yes, yes. Those rotating components will be there, na?
Yes, sir, exactly.
Whenever those rotating components are there, these accelerometers can pick up proportionate
Yes, sir.
vibration levels.
Okay,
So
thank you,
that
sir.
can be useful for our identification of the fault. We are measuring S4, S3, S4 vibration levels for qualifying their machinery.
Okay.
S3, S4 means this the nuclear submarine.
Yes, sir. Indigenous vehicles, sir. Now they're
They are
now.
now
Uh, okay, sir. Thank you,
constructing
sir.
at
Why is that now?
yes,
Okay.
yes.
No, sir. Sir, my second question. Thank you, sir, for this beautiful answer. And my second question is, sir, actually, of course, as of now, we talk only condition monitoring. But my question is, in stealth ships, exclusively underwater vehicles, submarines, see,
Okay.
controlling vibration in every important aspect. See, controlling the vibration is very important aspect, sir,
Yes, yes.
compared to the
True.
stealth technology.
Yes, true.
Sir, can you please share any kind of precision measuring tools exclusively for this stealth technology included one and its counter system in order to control the vibration, sir?
Yeah, there are many several techniques are there
Sir.
for basically vibrate. There are several parameters. The thermal imaging, like this funnels, turbine funnels diesel engine funnels will produce high temperatures, which is susceptible to measure the thermal imaging, the image by the enemies. That can be
Okay, sir.
measured by the thermal cameras, infrared
Okay.
thermographs can be
Hmm.
used. So, that thermal cameras will identify the hot spots of the ship or submarine. So, wherever high temperature is there, there will be some hot spot appear in the that spectrum. So that can be you can this funnel, particularly this diesel engine funnels.
Sir.
They produce high temperatures, exhaust gases. Due to that high temperature exhaust gases that can be appeared in the thermal camera. So
Okay.
that can be suppressed by using some infrared thermal suppression devices, infrared suppression devices like using some water cooling, mist like things can be used. NSTL has developed such device.
Okay,
IRS
sir.
infrared suppression device has developed for both diesel engines and turbine.
Nuclear. Okay.
Turbine.
So
So
thank you, sir. Sorry.
Thank you very
Thank you,
much,
sir.
sir.
actually, Ganesh Kumar sir can enlighten certain
Yeah, he is coming on offline, sir. He will do this.
offline. You can ask him. He is the key architecture of stealth technology.
Sure.
I am fortunate enough to work with him.
Yes, sir.
You can interact with
Definitely.
him. Mhm.
Definitely, sir. Thank you so much, sir.
So, thank you.
Sir. Hello, sir. Good evening, sir. This is
Good evening.
hello. This is Hanuman, sir. I am the adult faculty from NID Andhra Pradesh.
Right.
Sir, I have a doubt. Sir, all the instruments is the work here based on a contact base, no, sir? All the instruments contact base.
Contact base. Some
Sir,
displacement probes are non-contact probes are also there.
sir,
Displacement.
how to control the noise levels?
Again, you are coming to okay. How to control the noise means first of all you have to measure the noise of any equipment
Means,
which is producing.
what type?
Instrument you want?
Yes, sir. Yes, sir. What type of
Instrument.
instruments
So
are
sound level
nowadays?
meters are used for measuring noise.
Okay. For measuring control.
Manama,
Precision sound level meters are used.
Hello.
And this controlling noise is again using some barriers. acoustic barriers can be used.
Okay, sir.
So acoustic enclosures can be used. But, we cannot reduce the noise completely from the machine which is producing as part of inherent design issue. So you cannot reduce that design noise. You can suppress it by using some devices like enclosures and barriers, acoustic barriers. You can see that in our apartments and other areas, there are some generators are kept. They are completely enclosed with some enclosure. So they produce less noise when compared to open. In farmers use some type of generators, they produce more noise when compared to these type of enclosed generators. So that is one type of suppression noise in generators.
Yes, sir. Right now we are seeing in the apartments.
Yeah, in apartments we can see low noise generators, which are covered by some enclosures. So that enclosures will have the glass full serval type of elements. Um, uh, Material is used between the panels. There is glass wool or serval is fitted in the panels, so which can reduce transmitting noise from source to the listener.
Later, after that, have you applied sir, any filters like
Hello?
digital filter? Later, after that, have you filters? Have you used sir, any type of
Filters.
filter?
Yes, filters also can be used.
What?
Like silencers is another way of reducing noise. Reactive silencers and baffled silencers also can be used. Whatever we are using in automobiles, reactive silencers are used. That path, the noise path is directed in different ways. So there will be different compartments in the silencer. It is split into the path is split into different compartments, and the noise emanating from the engine will be reduced by splitting into several noise components. So, likewise, acoustic barriers also can be kept to reduce the noise levels.
Sir,
So
you
we
please
used
stop share, sir. Screen share.
some, sir.
Screen share. Screen share. You remove it, sir.
Okay, okay.
Yes, sir. Okay, sir. Thank you, sir.
I hope any other questions? Sir, actually,
Sure.
first time I listened very elaborate lecture from you, sir. Actually, today you are really from A to Z. You have given, I think, 2 week workshop is not required. You
Yes,
have
sir.
given completely on the basics to advanced level in condition monitoring with highlighting the case studies 1 to 5 you have given.
Sure.
It is excellently you have taken to all other HPCL like that also. Yesterday also docs are given on CFD. So I think these 2 days started with a very good stretch. This
Thank.
is really on behalf of our administration director, sir, all deans and HODs, Department of Mechanical Engineering, myself, and my co-coordinator Santosh. And really, the participants are also from 7 to 9:30. They are listening very happily. I request all the participants also, you please join tomorrow sharp 7 at IIT Madras. Rajiv Sharma sir is coming. If you don't mind, you unmute your mics and also camera and give a big claps to our Venkatratnam sir. All of you please unmute and give the claps. Cameras.
Thank, thank you very much, sir. I'm really honored and privileged for choosing me as a resource person. I would like to thank Dr. Sastri, sir, and organizers of this program. Thank you very much, sir.
Thank you, sir.
Thank
Santa?
you. Thank you to the participants
Sir,
who have patiently listened. Thank you very much, all the participants.
Yeah.
Sir.
You can, I have given my mail ID. You can interact with me at any time.
I have one question.
Sir. Yes. Rahul.
Can I speak, sir?
Yes, yes.
Sir, in underwater vehicle, what kind of battery you are using, sir?
What kind of battery?
Yes, sir. The material.
Under our vehicles, we are using lithium-ion batteries.
Okay, sir. The capacity, sir.
Capacity, I have no idea. For
Okay, sir.
propelling our torpedoes and autonomous underwater vehicles, we are using our own technology. We have developed our own indigenized lithium-ion battery here at MSU. There is a division called battery and composite battery division is there, and chemical division is there.
Okay, sir. Sir, another one question, sir. Suppose the first, the one time the battery we are installed in the underwater, how many days it will withstand the capacity of battery? You know it means.
This is not in my domain, but I can clarify.
Actually, Star is telling even it is not in domain, like controlling of noise, etc. I observed. Because Star is expert in condition monitoring only. But anyhow, with his expertise, he is clarifying the doubt.
Okay, sir. Okay, thank you.
Actually, our for our torpedo, battery lasts up to 8 hours. Lithium-ion battery. Once it is fired, it lasts up to 8 hours. Continuously, it can run. But our machine is only in minutes only. So that is why I am unable to tell you. There will be some life cycles for batteries and all. I'm not much focused on that. But our life cycle of our torpedoes and all in minutes only. 15 to our mission has to complete within minutes. Once the target is identified, our torpedo has to be released and go for attacking the target. So it should all happen within no time. So 15 minutes to half an hour is enough for our battery life. But if mission fails, mission is not successful, sometimes we may not. We may track the target, and it may use some other techniques to miss out. At that time, that battery has to be work for recovery also.
Okay, sir. Okay, sir. Thank you, sir.
Thank you, sir.
I think you may not reveal all the things from MSc.
Okay, it's okay, sir. He is interesting, maybe in power management of underwater vehicles. You can contact me later. I can.
Through email you can contact. Sir,
me. I can clarify you.
Yeah, I will put in the chat box email, his email. If anybody wish to clarify anything, you can. Sir, shall I give your email ID?
Yes, sir. Yes, sir. You can give.
I will give his sir email ID. If anybody wish to share your views, questions, etc., it will be helpful. Sir, with your permission, shall we close this session?
Yes, sir. Thank you. Thank you very much.
Thank you very much, sir. Thank you.
Thank you, sir. Thank you.
Namaste. So, thank you all the participants.
Thank
Sir,
you.
with your
Thank you
permission,
all the
we are
participants.
closing. Huh?
Yes, sir. Yes, sir.
Namaste. Namaste.